taking on. You gotta love how in the video I got the lovely waste container sitting here. Okay. So in this, I want to show you guys what these precipitates look like. You can gather in closer. Nothing's going to hurt you. Okay, just don't touch it. Connor, maybe you want to get in the back. Don't touch it. I'm just kidding. Okay.
A little bit tall.
All right. So in this, I got three different reactions that I want to show you. So here on the ends, these two that look like somebody's really dehydrated urine.
Yes.
That is potassium iodide. Okay, so they're both potassium iodide. And right here in the front, I just have a simple thing of potassium chloride. So salt.
Just look at that. That is amazing.
You just look at it. Just look at it.
Look at it.
Wow, just look at it. Sorry, I thought I had it mixed up. It wasn't mixed up. Okay, and so that y'all are curious about, just because of our curiosity of all the lab equipment and stuff that we deal with, all these are just clamps. I'm using them as test tube clamps right now. Clamps. All right, so here's the thing: is I'm going to take, this is silver nitrate that I have in here, and I'm going to first react it with the potassium iodide. So you see how it looks like pee. I mean, there ain't no other way to describe it. It just looks like somebody's pee right now.
Apple juice. Yeah.
Sure, apple juice. Okay, I know that right there does not look clear, but this is a clear liquid. I'll show it to you here in a second. But watch what happens as I drop it in. This is the formation of a precipitate. See the cloudy murkiness?
Now it looks like beer.
Now it's beer. I mean, there's no other way to describe it, Miss Shaw. I'm all up on you, but I'm getting the best pictures.
That's fine. Just make sure it gets pictures of the whole class.
I am. Like,
Okay.
I'll watch this. I got you.
All right, so in this, so right up here at the top, what you're seeing is that silver nitrate's reacting with that potassium iodine, and literally what you have is the potassium and the silver are flipping out. Okay, so what's happening is the silver the potassium's flipping over to form potassium nitrate, and the silver's flipping in to give us our silver iodide. Okay, so here's the thing, is so that you can see, this is probably the best example for, I don't need 50 pictures, Maddie.
I got you, though. You can pick from any of them.
I don't need 50 pictures.
But you can pick from any of them, so that way you get the best one.
Okay, so that you guys can see this. This right here will be the best one, because this is the ones that I really enjoy. So I'm going to use this pipette, and so you guys can see that is a clear liquid. Okay, silver nitrate is clear. This looks like water, but this is not water. If you drink this, you're going to the hospital. It's not going to be a very pleasant day for you. So don't drink it. But you can see that it's clear. The potassium chloride is clear, but here's the cool thing that happens is whenever we drop this thing in here. So now these ions are flipping spots.
Now it looks like cream soda.
And you can see the cloudy murkiness in there. So now we have got, now both of them were a clear liquid, but now you have got to the point to where you have a solid in there, that precipitate, and you still got a liquid in there, which makes it look like really horribly bad milk that nobody would want anything to do with.
Why would anybody have anything to do with milk anymore?
Milk is great. Maddie, you're on a 5-minute no talk time. Okay, and then this next one is this potassium iodide, and we have I have copper 2 nitrate here. It's pretty in blue, like my gloves. Very nice. So in this reaction is going to end up in something that looks nasty and gross, but it gives you the same idea. It's going to form a precipitate, but it's also going to give you all iodine as well.
Now, would you look at that?
So on this one, you can see the difference in the two. You see the really dark brown, murky, looks like a baby's diarrhea poop in a diaper.
Not quite.
With the same point at it. Okay, don't smile. It's no. Oh God.
Hey, now, Mr. Hall, that's ignorant.
No, whenever I'm coming around getting pictures of y'all, I'm not sitting there staging pictures of at Westside High School. We're doing chemistry. That's stupid.
Action shots.
Whenever I'm walking by and I'm taking pictures, because nobody's looking on the county page and saying, "Oh, well, they're just staging pictures. They ain't doing nothing in Mr. Hall's class." No, you absolutely are. Okay. So this is what it looks like. Does this help you guys imagine like what we're talking about whenever these reactions taking place and these precipitates are forming? Is this helping y'all? I feel like y'all have already got the NyQuil days. I'm done with this day.
These little bubbles.
Okay, that's not bubbles. Actually, that is the solid falling to the ground.
It's the ground?
Well, to the bottom of the test tube, sorry. Okay, so this is what you're looking at. Now in this, this is what we're talking about when those precipitates are taking form. Okay, so do you guys have any questions with these? All right, so in this, hopefully that helps you guys out, okay, in a visual representation of that, which that was the goal. Reminder, tomorrow what you have lab. So if you have not brought in the proper
Materials.
chemicals for our lab, you need to make sure and bring those in to me by tomorrow morning. Okay, so we can make sure and get those so that we can experience. So in this, we got a couple things to talk about on this double replacement reaction before we're finished. So in this, we had started talking about the formation of water. We literally just got right into it. From an acid and a base. Okay, so we literally just got right in the heat of this. Just got right in it. And we started talking about how you'll have an acid and a base. And what was the key to determining whether you had a base or not? If it has hydroxide. Okay? If it has hydroxide in it, at the end of it, you have a base. That's typically what you're going to be looking at for in this class for your basic level chemistry. So this acid and base will react, and whenever it reacts, it's going to form a salt and water. I feel like every time I say a salt, and I say it real fast like I'm saying a salt.
Salt and battery.
So this is what you're looking at, and yesterday, what did I do? Hydrochloric acid and sodium hydroxide? Okay, so we started with this as hydrochloric acid, which is like your stomach acid, and a strong base of sodium hydroxide. And this is the part that, like, when we got to it in AP chemistry when I was in high school, we got all excited because you know what happens when you combine a really strong acid and a really strong base? Nothing.
Water.
You get salt. So literally, what happens? The hydrogen and the sodium flip spots. So we get salt as sodium chloride, and then we get water.
And it's balanced.
Okay, now that is a special case for the double replacement, but it still fits in the same thing. If you'll just flip two of them, just flip what you start with. Take the hydrogen over and pull the sodium over. It works for you, and you'll be fine with it.
So salt will always have sodium.
Salt will not always have sodium in it. salt will always be group 1 or group 2 element along with a halogen. Or you can look at a group 1 or group 2 metal along with a non-metal. Fills into that area. Okay? So, within this, I want to give you guys a shot at one, okay? Before we jump on here. And I'm not going to worry about this as much. Now, I do want to stress to you guys, don't worry, okay? I know what's coming, but I'm going to ask for your help. On Monday, whenever we start practicing all these, please do not be the kids that just sit there and do nothing. That I hand you the paper, and you literally sit there and go.
Can we try one where we find the reaction?
Yep.
Okay.
Don't just sit here and stare at the paper and do nothing. I know right now you have a lot of information in your head. There's a lot of information in your mind, and you guys haven't had time to practice with it yet. I'm understanding to that. I'm not going to look at you and give you Monday and then Tuesday start stoichiometry. That will completely leave y'all in the dust. Okay? I'm not going to do that to y'all. We're going to take plenty of adequate time next week to work at these, but it's a two-way street. We both need to work at it. Okay? If you have questions, you need to ask me. But don't be going nuts on me. If you got no idea what's going on, don't be sitting there saying, I have no idea. I don't know what I'm doing. Right? Because whenever that's all going around the whole room, it goes nuts for me. And then I get stressed, and my anxiety shoots through the roof, and I'm just like,
Me too.
and I'm on edge.
Minecraft.
Okay? So, Mr. Hall does a double replacement reaction. And whenever he does this double replacement reaction, he finds the products to be.
But now we're in the
Dihydrogen.
all would like to know what the discussion was about.
Actually, I don't. I just know it wasn't chemistry. Dihydrogen monosulfide and iron 2 chloride. Give me a properly still can't even say it now. I got so tongue tied. Written chemical equation for this double replacement reaction. Yes.
Why didn't we balance the last?
Because it's already balanced.
Oh, it was balanced. Yeah, it was balanced. You're chopping hydrochloric acid and sodium hydroxide, right? Yeah, it was balanced.
Yeah, there's
Because there's a hydrogen with the hydrochloric acid, and then there's a hydrogen within the sodium hydroxide. Alright, so in this, first thing you're going to start with is getting these formulas down. Okay, so we're going to bring this down. Dihydrogen monosulfide, so H2S. If you're not able to go from this to this,
you need help.
you can see. Plus iron 2 chloride, so FeCl2. Those are the products. So now you gotta get the reactant. It's a double replacement. Just switch the 2 in the front. Switch the 2 in the front. Hydrogen, iron. Flip them around.
So it would be.
Whenever you do that, it's going to be iron will bond with the sulfide. Now in this case, what's the charge on the iron? Plus 2, what's the charge on the sulfide? -2, so it's 1 and 1, so it's just FES, what I got wrote there.
So it's gonna be H2Cl2.
No.
Oh.
What's the charge on the chlorine? -1. You put H here, it gives you an acid. What was the rule always with an acid? Number of hydrogens for the charge. So we just need 1 hydrogen. Now we have the chemical equation, we just need to balance.
Let's go.
Okay, if you're getting this, that is great. Oh, there's not
What's that
everybody is.
name? Is it hydrochloric acid? This HCl? I was literally just asking a question.
Hydrochloric acid.
Okay.
Do not start the statement with, I don't know what that means, though. Not in my class.
Yeah, but the way you were looking at me, I was like, I just asked a question.
You looked at me, and when you looked at me, you were like, I don't know what that is. And then you were like guessing for a name. Your name was right, but still, when you were guessing for it, I was like, how long did I spend on nomenclature? Come on.
You're going to put a 2 in front of the H.
I wasn't.
So 2 in front of the hydrochloric acid, because I'm looking at balancing the chlorines, that changes my hydrogens and the chlorines. Because the 2 hydrogens, 2 chlorines up on the reactant side, and we are now balanced. Okay? We will work at these. Okay? Next week's going to be a whole lot of practice. I crucially recommend you spend an adequate time studying throughout the week. Especially because there's a lot of stuff going on, okay? So, work at it. Girls, y'all win tonight, you go to state, I'll work with you. We'll figure it out.
Huh?
She's looking at here to take your notes. Wins.
So,
Wait,
that,
it's on Friday? Do we not get out of school?
We'll probably get out Wednesday. And then depending next one again.
I didn't say,
What is
now
this Friday?
listen, if we got out our freshman year for the boys to go to state, we best be getting out for the girls.
okay, so in this is chemical reactions. We are finally to the last chemical reaction. Okay? Tomorrow I will not be doing a demonstration because we got the lab, but the next demonstration I will do is this one. We are now going to talk about my personal favorite one. Combustion reaction.
Pretty funny. Like a commercial. This will help we get combustion.
Listen.
If I had a tissue, I'd have let it out, but
Thought of it as occupation.
So here's the thing with these combustion reactions. You already got some notes on them, and we're going to jump back into it. The combustion reaction.
Combustion. Fire.
This is perfect example of fire.
Wait.
This is what's happening within a combustion reaction.
That's like what's on the packet.
Exactly.
So literally, a fire that's burning is a combustion reaction. Whenever you're burning something, combustion reaction. This is what you're getting from
Do you
this.
work for Taco?
So in this,
That looks just like the packet.
in this, you're going to need certain things.
What is it?
First thing you're going to need is a fuel source. Your fuel source.
This whole.
Alright, so the first thing is your fuel source. In this class, what you will be seeing as your fuel source are hydrocarbons.
Crazy.
What am I doing that for? I should have capitalized that. So you'll have your hydrocarbons. Now this is the thing with hydrocarbons. They're going to have carbon, hydrogen, and just for the fun of it,
Gas.
oxygen. So they are made of carbon, hydrogen,
Gas.
and oxygen.
That is a treble.
Okay, and
I don't care.
Carbon, hydrogen, treble, and oxygen.
Now, what, Mr. Hall?
So hydrocarbons. The next thing you're going to need, good old everyday oxygen.
Gas.
if you start a fire, it will go out.
Exactly right. Fire can't breathe, no oxygen getting into it, it will stop. It will no longer
So you gotta
burn.
have oxygen,
Why?
and then
What is reacted for a combustion reaction?
oxygen.
Oxygen. Now we'll go on and tell you this. This oxygen in this case is excess. Which means there's a whole bunch of it, you need however much of it you need.
That's very complicated. Yes. It says oxygen.
I'm going to say this so that I have this recorded in case anything gets misconstrued and said against me. If you're coming in this class and you're not taking notes, if you're coming in this class and you're not working at this, you are 100% at a great risk of failing, because it's going to get harder from here, and everything that we're doing is going to build off of this.
Not if you have a rabbit's foot.
So, if you want to play this game, play this game. I've failed kids in the past because you earned your grade. If you're not willing to work at it, that's fine. Whenever I get your quiz turned into me and it has nothing on it, that's totally fine by me, because that is absolutely the easiest quiz to grade. So, this is your choice. But I am not going to take the blame for you. And if a parent wants to come have my head because you're failing, I'm absolutely throwing you under the bus. And say, well, they want to sit back there and not take notes and not do anything. It's on them. Because I have videos of me instructing. And my favorite thing is whenever I get emails from parents that say, what I taught in class is not what the quiz was on. Because then I get to sit with, I could literally sit with the videos and go question by question and show, yeah, I taught that. So, you can create all the excuses that you want, but at the end of the day, there's enough evidence out there to show who's really going to be involved. Anyway, so within this,
That deserves a grade.
you have these. You have hydrocarbons and oxygen. Along with this, for a combustion reaction, if you're going to start a fire, you need to throw something within
You're
it.
going to say fire. Hey.
Heat, baby. We need some heat. Heat. We throw the heat up in there, reaction starts taking place, and here's the products that get formed.
You don't want the burn on
Carbon dioxide and
Mess with
the boys, gonna get the
water.
That's fine.
I'm going to be completely honest with you. This should be the easiest reaction you deal with. You know why? You don't know nomenclature for organic chemistry. have to give you the chemical formula for the hydrocarbon. All you do is you take the chemical formula for the hydrocarbon, plug it in here. So literally, this is what you're looking at. Hydrocarbon chemical equation, right, chemical formula right there. Plus O2, because diatomic reacts with heat to form carbon dioxide
That's it.
and water.
And then we'll do that.
This is literally it. You take the hydrocarbon I give you, plug it in there, balance the chemical equation. It doesn't get any simpler than that.
There will always need
That
to
is
be
so
that.
easy.
The only issue with this is some of you guys had mentioned this whenever we was balancing those chemical reactions, that you were struggling with the fact whenever you stuck a number in the middle and you would divide by 2. These are the ones that have that in it. That's where the majority of those will be safe.
It's like constant.
It's not going to be a problem though. You're ready for this. And you got this. So, the perfect thing for this is if I took ethanol and I performed a combustion reaction. What would a properly written chemical equation look like? Ugh. I can't talk to that. Ethanol is CH3, CH2,
Question.
OH.
No, I'll give you a chance to actually answer. See if it does.
What?
Why don't you just
Whoa,
put the
no.
carbon and
Oh.
carbon
Because that is how you write it out. Yes, it's always going to be O2. It'll never change.
It sounds like a.
No, you're fine. This right here, this is the only thing that will be changing in this class for a combustion reaction. Your hydrocarbon is what will change. I will not change anything else on you. You must have oxygen. You must have heat. It will always produce carbon dioxide and always produce water. So now in this, life gets fun. To answer the question and why this is wrote out like this, the reason that's wrote out like that is because that is an organic molecule. That's how we write organic molecules. You'll learn about it in organic chemistry.
What does that make?
What?
That molecule.
ethanol.
So within this, when we're balancing, you got to be careful here. 2 carbons. There's the first one, there's the second one. Hydrogen. 3 plus 2 is 5 plus 1 is 6. Oxygens on the reactant side, 2 plus 1 is 3. And here's the really cool thing. Your product side over in a combustion reaction is literally as easy as 1, 2, 3 if you get it lined up right.
No.
1, 2, 3. 1 carbon, 2 hydrogens. 2 plus 1 is 3. 3 oxygens. So now in this we go and we try to balance. So in this case we're going to go carbons first. I have 2 over on the reactant side, I need 2 on the product side. So if I put a 2 here in front of this, it changes my number of carbon and my number of oxygens. I now have the 2 carbons, but I now have 2 times 2 is 4 plus 1 is 5. 5 oxygens. So I need to balance the hydrogens now. And the reason we're saving the oxygen for last is oxygen stuck right here by itself. So we got to balance the hydrogens. So we'll stick a 3 in front of the water. So hydrogen and oxygen is now changed. I now have 6 hydrogens, but I now have 3 oxygens plus 2 times 2 is 4. 3 plus 4 is 7 oxygens. The carbons and the hydrogens are balanced.
So we're just going straight for the oxygen.
Now let's go for the oxygens. Now I can't remember if I mentioned this trick in here or not. I made this a whole lot more confusing than what it needed to be.
3 in, and that'd give you.
Can't plug a 3.
Wow.
You're thinking of the right number. But here's the thing. This is the thing that you guys said was a little confusing. I want to say it was somebody in 5th period. I'm going to give credit where credit's due. I'm going to give honor. Oh, God, it's going to be hard. Christy Martin. Shoot. God help me. She pointed something out that I'd never noticed before, and I apologize to you. I'm going to point this out to you if I haven't already. Take this number, so 7, divide it by what's over here. So the oxygens are 3. So 7 divided by 3. I said look at your fraction. No, I said look at your decimal and then you figure from there. Christy has 1,000 times better method. Because right now if we wrote this in, we're going to have 7 over 3 here. Multiply all your coefficients by whatever this number is. So your denominator. So we're literally going to multiply everything by 3. So in this case, 3 times 1,
Didn't I just say?
3. I thought you said toss a 3 in there. Seven thirds times 3. 7. 2 times 3. 6. 3 times 3.
But why would you do that?
Yeah. When you-
Because-
Fraction.
Hold on.
You could have just
You
put
could
a
have just
3
put a 3 in front of the O2. That gives you 6
That's what
plus
I
the 1 in the.
That's what I was
Like,
thinking, because that
There's
would give you
no
6 plus
sense
1
in all.
It's 7.
is 7. Like, why couldn't we have just done it like that? That's what I was talking.
If you want to do that, do that. But
Would it be counted wrong?
no, it's not going to be counted wrong. I'll look, but I'm going to say this. In a lot of things that I like to do, I like to teach you guys a pattern to follow. Because this is your first time ever seeing it. This is a very rare occasion. Extremely rare. Normally I'm just going to give you a carbon and hydrogen here. But because I gave you an alcohol with this O in here, that's a different circumstance. Either way you want to go about it, you can go about it.
If you want to balance it all
Because that's
out,
what I
and
was
there's no
thinking,
way to
because
just add the one on
if
there
you would've
and it's
just
uneven, then yeah,
Times
you
it by
can
3.
do all that.
It gives you 6 plus 1 is 7.
But in this rare occasion,
You can do it either way.
you can do it either way, but like, you went through there almost all those numbers.
So like whenever you're balancing, you can keep your pellet columns together to show up on both sides, or you can break them apart. It's whatever you want to do. As long as you can balance it, it's fine. I like to give simple patterns because chemistry is hard enough as it is. If you have simplistic patterns, it helps a whole lot. I absolutely understand where you're coming from, and you are absolutely correct. You could have did it. I wasn't thinking about that. I was just thinking about the pattern. My apologies. Ivor, you're right.
Either way.
If you want to do that, do it.
Christie's way works.
But this is the way that I like to run about it. Okay? Yeah,
So you said that.
you have got to speak up.
You said he's like put in the question, Mr. Holmes went down and like mixes ethanol in a combustion reaction. Are you going to give us the formula or are you just going to like ethanol?
You don't know organic chemistry nomenclature. I have to give you the hydrocarbon. That's why these are so easy. I literally give you this. What's in the purple here, I give you. This, I don't give you, but it never changes. You literally just plug the hydrocarbon in. I always give you the hydrocarbon. And I gave you the name in that case. I said the name because I was going to write the formula here. I will give you the chemical formula. You have to have the chemical formula. Alright, so in this case, 3 up here, so 3 times 1, 3 times 1, add those together, gives you 6 carbons. Hydrogen-wise, 3 times 3 is 9, 3 times 2, sorry, 3 times 2 is 6, and then we have 3 times 1 is 3, add those together, 15, 18, so we have 18 hydrogens, and then oxygen-wise we have 3 from the hydrocarbon, and 7 times 2 is 14. 17. So over here, carbons, I have 6. 6 times 1. Hydrogens, 9 times 2 is 18. Oxygen, 6 times 2, 12. She didn't work.
So why don't we just do it my way?
Special occasion, do it your way.
But it
On
didn't
my way, it
work.
came out balanced.
Oh, snap.
Hold on, Mr. Hall.
Unless he added it.
Add 4 or add 2 right there. 1 row 2. Make that a 9. No, then it's balanced. There you go. You're balanced.
Now are you a big doctor? Alright. There's your combustion reaction. We have now finished the 5 types of reactions. Tomorrow will be lab. We get to chill, hang out. We get to examine chemical and physical changes. From there, chemical and physical changes that we deal with. Be a great day tomorrow. If you haven't brought stuff in, please bring the stuff.
I told you about it.
She showed that